Alright, our homework. You should have already checked your answers online. But there were a couple that gave some people a little bit of trouble. Mainly because they weren't in standard form. So, for example, 35. It's not in the standard form. Well, yesterday I even showed you the A, right? So if it's not in standard form, bless you, you have to change it into standard form. So I would want to rearrange this to be y equals the absolute value of negative 2x plus 4, and then that's technically plus 0. And then I can identify that this is my m value, this is my b value, this is my c value. Then use your formula for the vertex. So the opposite of b would be negative 4 divided by, hold on. It is negative b. I started plugging it in right. Negative 4 divided by negative 2, comma, c, which is 0. It's the opposite of b over m. That's what the formula is. Negative b over m.
I thought m was positive.
The opposite of b over m. This is the formula. You have to memorize it. So it's not just that's your y-intercept anymore. When you're talking about your absolute value graph, you have to find the vertex, which is the min or the max. And this formula is used to find it. Okay? Memorize. So it's always the opposite of b, negative b. If it were negative, it becomes positive. If it's positive, it becomes negative in our formula. You're going to learn y today. Okay, we're going to learn that this number will indicate a shift left or right, and it does go the opposite direction that you think it would. But we'll look at that today. And then once you got your vertex, of course, creating your table of values, putting that one in the middle, picking a couple numbers smaller and a couple numbers bigger, and then plugging them in by hand and evaluating. Once you get your points, plotting them. Okay? Which other ones do we want to go over? There were some tricky ones on the back, perhaps. We might have questions on. Jacob? 43. 43, same thing. First thing we have to do is get it into standard form. Because right now it doesn't look like this. Okay, so 6 is a positive. So if I want to move this to b over here, this is going to be y equals negative absolute value of 3x, technically plus 0 if that helps you, okay, so that it matches up. And then it will be plus 6. You can't just change this to a minus 6. Subtraction is not commutative. You're not allowed to just flip it. Like 2 minus 3 is different than 3 minus 2, right? So make sure that you don't do that. Then from here, I would identify this is my m, this is my b, and that's my c. And then plug it into our formula. Identify our vertex and find some values. Okay? Which you can see I did that here. So the vertex ended up being, again, this was plus 0. So the opposite of b would be negative 0 divided by 3. Negative 0 is just 0 divided by 3 is still 0. And then the c value was 6. And then I plugged those in to get my graph. If you do these by hand, which you get to use a calculator on Friday. So if you want, you could use the table feature that I showed you. But you'll still have to find the vertex by hand. If you were to get a point like up here, and like all of your other points were down here, make sure you check your algebra, because you might have just made a sign mistake somewhere. That's fun.
If our lines are exactly like yours,
If
our vertex is cool, but like everything else is like kind of like slightly off or something.
Slightly off, you'd probably lose a point.
I really can't.
But on the quiz it will say, create, after you learn today's lesson, we're going to learn shortcuts that you just shift them and you won't have to do this. Okay, but there will be one question on the test and one question only that says, first find the vertex, then create a table of values and graph. It says you may use the graphing calculator. So if you want to type the equation in your y equals and press second graph, remember, if you press second graph, you get your table. You could just copy this down on your paper, okay? And then plot them. So if you're plotting, 4 points, 5 points, and then drawing your lines, they should be pretty straight as long as you plot them. Okay, but it will make you create a table of values, either doing them by hand, algebraically, or with the graphing calculator to help you. Okay. Other ones we want to go over? Okay. Last section before we review tomorrow for the quiz, which is Friday, is families of functions. Okay, which we are focusing just on the absolute values, but eventually later in the year we'll look at quadratics, and they're all kind of the same thing in terms of families. So a family of functions is made up of functions with certain common characteristics. So the parent function is the simplest function with these characteristics. So there's a linear family of functions. They all form lines. There's an absolute value family of functions. They all form V's. There's a quadratic family of functions that all form a, what this called? A parabola. Okay, we'll also learn about cubic and quartic ones this year. Okay, so for linear, does anyone know what the parent function is for a linear? The simplest form of a line? Y equals x. Technically y equals 1x plus 0, right? Okay, it hasn't been shifted at all or stretched to make the slope different. So the absolute value parent function is just y equals the absolute value of x. Okay. Today we're going to take the parent function and we're going to do translations with it. So we're going to shift it left, right, up, and down just by looking at the equation and the rules. Okay.
Mrs. Willis, will you please dial extension 6505? Mrs. Willis, 6505.
And the parent function for a quadratic is just y equals x squared. And we will do a lot with that this year. So the translations is how you can shift the graph either vertically, horizontally, or both.
Please excuse the interruption. Tyler Weller, please report to room 268. Tyler Weller to 268. Thank you.
Okay, so the vertical translations will be shifting it up or down. So if you see a plus something at the end, outside the absolute value, like plus 2, plus 5, that is going to shift it up however many units. If you see a minus outside the absolute value, that's going to shift the parent function down k units. Okay? And we'll actually see numbers instead of variables when we look at those. Okay? So, describe the translation, then draw its graph along with the parent graph, which this is the only one we're actually going to draw both of them. Otherwise, we'll just graph the equation. So first of all, when they ask you to describe, you just have to look at it and see, oh, there's a minus 2 at the end, so that means that it's going to be shifted down 2. Okay, now the parent function, remember, is just a plain old y equals absolute value of x, which starts at the origin. The origin is your vertex, 0, 0. Okay? The one side will have a positive 1 slope, and the other side will have a negative 1 slope. So you're going to go up 1 over 1, 1 over 1, and also up 1, backwards 1. And then we'll connect the dots. Now, since we're going to graph 2 equations on the same graph, at the tip of one of the arrows, just write that this is the parent function, y equals the absolute value of x. And I'll use a different color for the other one. Now we're going to graph the translation. So we are going to shift the whole graph, slide it down 2 units. Usually I take the vertex and I just shift it down 2 units. And then instead of going point by point, once you move the vertex and you observe that the slope is still like a 1, so you can just go up 1 over 1, up 1 over 1. And then at the tip of one of those arrows, I'll write y equals the absolute value of x, and then close my absolute value bars minus 2. Okay. So for the next one, we are going to graph it. We're not going to do it with the parent function. We're just going to graph the new one, just so we don't have to do that every single time. So this one has a +1 outside, so that's been shifted up 1. So again, you want to imagine the parent function starts at 0, 0, so I'm going to shift the vertex up 1. We aren't seeing any changes in the steepness of it, so we just go up 1 over 1, up 1 over 1, and up 1 backwards 1, up 1 backwards 1. And again, since there's only one of these on your quiz, like take the time to put a few more points so that when you do draw your line through, it looks better. Oh, no, I did describe up here. The next few ask you to write an equation that would represent the translation. So we're moving it up 8 units. That'd be y equals the absolute value of x plus 8. Now, be careful. If you were to write this, you would be marked wrong. We're going to learn below on our notes that this would be a shift left 8 units. Okay? So it's not these aren't difficult questions, but if you don't memorize, you'll get them all backwards. Okay? So it has to be outside of the absolute value. The next one is shifting down 1/2 unit, so we would subtract that at the end. And shifting up 3.5 units, we'll add 3.5 at the end. Okay, so simple, but again, it's just making sure you memorize the rule. Okay, now let's look at the left and the right ones. Oops. So, if you see a subtraction inside the absolute value bars, that is going to tell us to go to the right. It's a shift right. Now, when you look at the graph, normally you would think to the right was positive, because like the left is the negative x values and the right is the positive. So some students like to remember that these are the opposite direction that you would think. Usually if you see a minus, you would think negatives go left, but it actually goes to the right. Okay? And that's why whenever we do our vertex, we take the opposite of B. Okay? And if we see a addition inside, that's going to be a shift to the left. Okay, another way to remember it is that when you see the plus sign, there is a plus sign in the letter F and the letter T, if that helps you remember. Now some people will be like, there's a plus sign in the letter T, right, also, but this one has 2 plus signs hiding, which is our plus. So example 6 asks us to look at the graph and write an equation to describe the translation of x. Who thinks they could tell me what our equation would be? Mason?
Y equals absolute value of x plus 2.
Close. It's not going all the way over to 2.
Oh.
So it's going, I think, it looks like 1.5. And again, make sure that's inside. And that's because it went to the left 1.5. Okay, now we will mix and match these. So we might end up shifting it left 3 units and up 2 units. And then we're also going to look at examining the stretch and shrink in the next few. So, see if you guys can go ahead and do 7, 8, and 9. Again, just ignore the and its parent along with the parent function. You can just graph the regular line. Okay, so see if you can describe the translation and graph it. All right, now we're going to combine them. Left and up, right and down. Make sure you don't put them in the wrong spots. So we have right 4 units. Right 4 units means that I would subtract 4 inside. Down 3 units means that I would subtract 3 outside the absolute value bars. So if you want to jot down a little reminder to yourself, you can. You don't have to. Absolute value of x minus 4 minus 3. You will have a graphing calculator too, so if you wanted to type these in your y equals and check them, you could, but take you a little bit of time. Now for this one, I am going to darken my x and y axis. It's kind of hard to see them. They kind of all look like the same color to me. Ooh, before we do this one, let's go to the vocab below. Because do you see how this one's facing downward? Okay, that, we need to go over that word. So that is talking about a reflection. Okay, so what a reflection does is that it just flips the graph, basically, but it will change the y values to their opposites, thereby reflecting the graph across the x-axis downward. So anytime you see a reflection, it will be like this, negative absolute value of x, and so it's a negative out front. And anytime you see this, this will tell you that the graph is facing downward. Okay? So it has to be negative out front of the absolute value. If you look back at your homework last night, any of the ones with the negatives, you'll notice that the graphs face downward. So, now we go back. So first of all, we notice that this one is going downward. So that's telling me that it is a reflection. Also, it's been shifted how many units in which direction. The vertex, again, normally starts at 0, 0. So it's been shifted how many units? What way? Nathan?
1 to the right.
1 to the right and
2 down.
2 down. Doesn't matter if you put 2 down first and then 1 to the right, doesn't matter the order. Now just make sure you put those in your formula properly, and also make sure you take into account the reflection. So this would be negative absolute value of x, is it minus 1 or plus 1? Right, minus 1. And then 2 down would be minus 2 outside. Okay. All right, the last thing we're going to look at is the a variable, which is going to affect basically the slope or the steepness of the line. So the vertical stretch will multiply all of the y values by the same factor that is going to be greater than 1, thereby stretching the graph vertically. So an example of this, first of all, you can see it down here. The stretch and shrink is the a variable that's actually in front of the absolute value. You never distribute it. A couple people ask me about that. You never distribute it. So if you see y equals 3, absolute value of x, that would be a vertical stretch. Now, how a stretch happens is it takes the tips of the arrows, imagine that my fingers are the tips of the arrows, and it stretches them. So the line actually becomes steeper than it was. Basically, it's going to act like a slope. Okay? Instead of going up 1 over 1, you would go up 3 over 1, up 3 over 1. The shrink is going to take all of the y values, and it's going to multiply by the same factor that is between 0 and 1. Okay? If you have a negative also, that's going to just reflect the reflection. So for example, y equals 1/2 times the absolute value of x. Again, a shrink would take the tips of the arrows and it would shrink them down, which will make it less steep. So the graph would go like up 1 over 2, up 1 over 2. Something like that. So it'll be flatter. All right. So drawing and graphing some of these, again, we're going to skip the parent function. When you describe this, you should say that this is a vertical stretch. You could either say of 3 or by a factor of 3. And then whenever you graph it, since we haven't shifted it at all, always look, because on your homework they may combine all of them. You might have to go left, right, up or down. And then this does not affect where your vertex goes, it just affects your next point. So it's still at 0, 0, because we don't see any plus or minus. Instead of going up 1 over 1, we go up 3 over 1, and up 3, and backwards 1. And since there's not a lot of grid lines, that's really the only points I can fit on there. The next one, you can see that 1/3 is between 0 and 1, so it's shrinking it vertically. This is a vertical shrink. And you can just say of 1/3 or by a factor of 1/3. And again, that's because it's taking all of the y values and reducing them by a factor of 1/3. So to graph this, we would plot, see if you shifted at all, which we don't, then do our slope, which will be up 1 and over 3. Okay. See if you guys can try the rest of them. And then we'll go over them. These should be pretty easy. (16). Be careful. Who can tell me what they got for their equation? Marin?
Y equals -1/2 absolute value of
Okay, close. The negative, make sure you have it, because it is reflected downward. You're telling me that it goes down 1 and over 2 by telling me it's 1/2. It should be -3. So it's going, here's my vertex, to get to the next point, which is here, I'm going down 3 and over 1. Okay? And be careful of 17, it did say write an equation for the reflection and the vertical stretch. So that should be y equals -5 absolute value of x. So look for that keyword reflection that inserts that negative. Okay, and then our closure question, which there are a couple like this on the homework. Since there's not like grid lines going through all of them, some of you may have trouble figuring out where the points are. So if your answer when you're checking your homework is like slightly different than mine, that's okay. On your quiz, I made sure they all have grid lines everywhere, so you can clearly see where it intersects the coordinates. But this one you should be able to figure out just by process of elimination. What do we think? A, B, C, or D? Come on. C. It's definitely not B or D because they're not linear, they're absolute value. And then based on the graph, it is a reflection, so it has to be negative. Okay.